Okay, boys and girls, today we're going to do transformation of functions, day 3. This is lesson 4 in your packet. So for the first question, it says given g of x equals x squared minus 1. They want us to state what the parent function is. In order to state the parent function, we have to know what kind of function this is. So since we have that x squared, we know that it's a quadratic, and the parent function of a quadratic would be y equals just regular x squared without the plus or minus of any other numbers. You could also have written f of x equals x squared or anything else, as long as your function is the x squared. Now for the transformation, we have that minus 1. Since the minus 1 right here is on the outside, there's no grouping symbol, it's on the outside. We know that it's going to be a shift down 1 unit. Number 2, we have the function h of x. Now, hopefully you notice this square root symbol. The square root symbol means it's a square root function. So the parent function here is just going to be y equals square root of x, or again, f of x equals square root of x. Now there's two transformations being applied to this function. You have the plus 2 on the inside of the grouping symbol, and then we have the minus 5 on the outside of the grouping symbol. So since the minus 2 is on the inside, we know inside of the grouping symbol tells us to shift left or right, and it's the opposite of what you think. So we're going to shift left 2 units, and the minus 5 on the outside tells us we are going to go down 5. Now, if it was a plus 5, we would be shifting up 5 units. Okay, for question 3 through 5, I'm assuming that this should be a 3. Write the equation for the following translations of their particular parent graphs. You may use y equals or function notation, which means f of x. So I'll use the f of x. It really doesn't matter here, but we have f of x. We have to notice that we have a quadratic function, and the vertex of this function is at negative 5. So the parent would be just the regular x squared, but since this one has clearly been shifted to the left 5 units, we want to put the plus 5 inside of the grouping symbol, and then the square and the exponent showing that it's a quadratic. The next one, hopefully you remember how to write the equation of a line, but if not, we'll go through it. You need your m and your b. Your b is your y-intercept, and that's at negative 4. And then you also have to find your slope. In order to find your slope, you take 2 points on the line, and we go up 1, 2, and over 2. Our slope is 2 over 2, which means it's 1, and our function of f of x equals mx plus b, or x minus 4. The last one is an absolute value function, which means we're going to use those absolute value bars, and it's clearly been shifted up 1, 2, 3 units. So that means we're going to have that plus 3 on the outside of our grouping symbol. So we have absolute value of x plus 3. Okay, to intro you into what we're going to actually be learning about today, what type of transformation is taking place, we're going to complete this next question. So it says the graph of y equals x squared is shown below in bold and labeled. Which of the following could be the equation of the graph shown in dashed? So what I'd like you to do is, you can pause the video, put in y equals x squared into your y1 in your calculator, this original one, and then you're going to try putting in each of these and see which one you get that looks closely to this dotted one after the transformation takes place. So go ahead and do that now, and then you're going to pause the video, and then you're going to check. You should get, hopefully, option number 2. Okay, for the guided practice, I'm going to go to the key. I'm just going to show you a few things. So this is the answer key for question number 1. Now you should be doing this out, not just copying the key, but I just want to point out a few things for this question. And again, pause the video, do your best on it, and then watch to make sure it's correct or follow along. So we know that f of x here is the absolute value of x, and that g of x is the negative of whatever f of x is. That tells us that g of x is negative of whatever f of x is. So it's negative absolute value of x. So this one is negative absolute value of x, and this is absolute value of x. So after you graph both of them, you get this, this kind of transformation on your graph. And you see that the first one is flipped over and becomes this second absolute value function. And the goal of this question is to realize that if there's a negative outside of your grouping symbol in the front as like your almost like your leading coefficient, that's going to say that it's a reflection, and that reflection is over your x-axis. So it takes your function and it flips it over the x-axis. Okay, moving on. Okay, so our next one. Again, pause your video, see what you can do, and then you can take a look if you're correct. So you graph your function g of x, which again, it's 2f of x, so g of x is going to be 2 times whatever f of x is, so 2 times x squared. You graph the function and you realize that the only difference between them, hopefully, is that it gets a lot narrower, and that has to do with the number that's in front of your x squared. Since the number in front of your x squared is greater than 1, it's going to make your graph more narrow. It's going to get skinnier. So that's what's important to know. So far we looked at a negative in front reflecting it over the reflecting it over the x-axis, and then a number greater than 1 in front of your function tells you that your graph is going to get more narrow. Describe what happened to the function as compared to the parent function. Yeah, g of x gets more narrow than f of x. So hopefully you're starting to think, okay, well, what happens if the number is less than 1, meaning like a fraction, like we have right here. I thought I was erasing. Okay. So hopefully you kind of guessed if it's less than 1, then it's going to get wider. And really it relates to slope, because let's say like this line right here, let's like look at the slope. The slope of that line is just 1, right? So your slope of the blue line is 1, whereas your slope of the other line is up 1 over 2. So because it's less than 1, it's getting wider because the ratio of vertical to horizontal distance ends up making it smaller. So like your functions get wider, or at least your absolute value function, your quadratic function gets wider. And then it'll be narrower. Let's say that your slope is like 3, then you'd go up 1, 2, 3, and then over 1. So that would make it narrower. So those are like the differences in why your graph gets steeper and narrower. It's kind of related to slope. So make sure you have all this graph. Make sure you have your table always filled out. And then you can read at the bottom, it says describe what happened to the parent function as compared. Well, hopefully you realize that now it's wider because the number in front is less than 1. Okay, a quick summary is there are other ways to transform a graph besides translating, which is what we did the past 2 days. You can also use your graphing calculator to check anything that you do. So that's always a good idea. When we multiply a function by a number greater than 1, it stretches, meaning it kind of gets more narrow. And then if it's a number less than 1 or between 0 and 1, it's going to get like wider. So remember, the negative sign tells us we're going to reflect over the x. And then the other two are if the number in front is greater than 1 or between 0 and 1. Let's move on to some comparisons. It says, which of the functions represents a vertical stretch if this graph is this graph wider or more narrow? So the stretch is going to actually be the y equals 3 absolute value of x, and it gets wider. Which of the functions represents a vertical shrink? Is the graph wider or more narrow? So a shrink is actually this one. It's going to get wider, and that would be, oops, sorry for my handwriting. It's kind of hard to write on this. The y, oh my goodness. Y equals 0.5 absolute value of x is the wider one. Oh my goodness. Yeah. Okay. The one before that, I apologize. This one is more narrow, and you can obviously see the red is more narrow than the dotted line. Sorry, I'm going crazy. Okay, now we're good. And then finally, just to sum it up, number 4 says let f of x equal the absolute value of x represent the parent function. Write a formula for the function whose graph is translated, given by the instructions below. So a vertical stretch with a scale factor of 5 just means that we are going to put the 5 in front of our parent function. So I'm going to rewrite these as g of x just because they're new functions now. So it's going to be g of x equals 5 absolute value of x. And a vertical scaling is called a vertical shrink, which means it's going to get wider and it has a scale factor of 1/3. So we have g of x equals 1/3 absolute value of x. Number 5, let f of x equal x squared represent the parent, and write a formula for the graph. Write a formula for the function whose graph is the transformation of the graph f of x given by the instructions below. So now we're taking what we've done the past few days, merging it with what we're doing today. So we have a translation right 5 units. So that would be g of x equals, we want left and right are inside the grouping symbol. So I'm going to create a parentheses to show that it's being grouped. And we're going to go x minus 5 and put the squared on the outside. Next one is down 3 units. So the 3 goes on the outside of the grouping symbol. And we have g of x equals x squared minus 3. And then the last one, a reflection over the x-axis. So that's one transformation. And then translated up 2 units. So we have g of x. Remember, reflection means negative x squared. And then up 2 units means to add 2. Okay, I'd like you to try the homework. The answer key to the homework should be on Haiku right underneath where it tells you to watch this video. Do your absolute best. Please just email me if you have any questions whatsoever. Okay, have a great day. Hope everybody's safe and healthy, and I miss all of you.